Had a question on number 19 and 2.3. So this was an average rate of change problem. We were given this function and asked to find the average rate of change between 2 and then some value to be determined later if we cared, and that we're just calling that value b. And so it sets up the same as it generally would, f of b minus f of a over b minus a, and just in this case it's b and a happens to be 2. And then, so I set that up with my function down here. This came out 9, simplify, you get down to this step. And then right here it's a little bit tricky, so here's where you need to remember a little bit of factoring from the previous class and how to do a greatest common factor. There is a little bit of a review of that with a bunch of other stuff in quadratics in section 5.1 in this course. And you can also look up a really basic greatest common factor problem, but essentially I just wrote it out down here. In this case, 5b and 10 both contain this 5. So remember what I'm doing is I'm looking for the biggest thing that is in both of those terms, and I'm taking that out front. It's basically like doing a reverse distribute. Because think about when we distribute, we go 5 times b, 5 times 2. Now what we're looking for is taking that 5 out. So again, the idea is that you know this coming into the course, but you may not remember, so hopefully that's enough to rattle that loose in your brain. Back to here, so now I have a factor of b minus 2 up top and b minus 2 in the bottom. So if I have something over itself, that is 1, and so we can cancel those, and that leaves us 5. And remember, what average rate of change is finding is the average rate of change, which ends up being the slope between two places on a graph. And so in this case, this is a linear function we're going to find out. And so it has that slope of 5, and so yeah, what we're seeing down here is it's going to come out 5. Where that gets a little bit more interesting is for pretty much every other function in the world where the slope isn't constant, and then that's where this will start turning into calculus in a couple of quarters. Cool, so there's a little bit of help on number 19.